Greetings. This video is going to provide a short description of the course on control systems. As the course title indicates, this course is going to provide a broad overview of methods and ideas that can be used to design controllers for dynamic systems. So let me take an example to convey what this course would essentially do, right? So, if we consider a DC motor, for example, we give a voltage input to the DC motor and we get a rotational speed or RPM out of the DC motor. So, we consider the DC motor as a system to which a voltage is given as the input and the speed of rotation is obtained as the corresponding output. The question that we are going to ask ourselves is that if I want the DC motor to run at a given rotational speed, what should be the input or the voltage that I should be providing to the motor. So, that essentially defines this course. So, this course is about visualizing systems as entities to which we provide an input and we obtain an output from the system. The question that we are going to ask ourselves is that can I design some controllers which essentially would regulate the value of the system output around a desired operating point or around a desired operating region by varying the input to the system. So, that is what we are going to learn in this particular course. Who should be taking this course? This course is the first course on control systems and is ideally targeted at second year undergraduate students who have a background in basic engineering mathematics topics like algebra, polynomials, complex numbers, Laplace transform and ordinary differential equations. That is the background that is required for taking this course. Of course, it would also help people who are pursuing graduate studies who want a refresher on basic controls. They can also essentially gain information from this course. And this course would essentially start off by identifying the class of systems that we are going to study and learn how to characterize such systems as entities to which an input is given and an output is obtained. We would learn two representations of dynamic systems. One is what is called as a transfer function representation and the second one is what is called as a state space representation. This course would predominantly use the transfer function representation of dynamic systems for analysis and design. Although we would still learn what is called as a state space representation and that would be used in advanced courses in control systems. Once we learn how to characterize dynamic systems for the so called stability and performance, we would then go and learn as to how to design controllers that will essentially regulate the system output. In this regard, the class of controllers that we would be focusing on is what is called as a PID controller. P stands for proportional, I stands for integral, D stands for derivative. So, PID controllers are widely used in practice around the world in multiple domains. So, this course would concentrate on what is meant by a PID controller, what is the physics behind it, and then teach how to design such controllers given a particular system. We would learn formal methods to do it and we would essentially see how one can design the entire so called closed loop control system for their stability and performance. We would also learn how to essentially quantify performance. That is, let us say if I design two systems, which one is faster, which one will essentially follow a given desired input better. All those questions would be answered by quantifying the system's performance. We would also learn what are called as root locus methods, Bode diagram based design methods, Nyquist plots and Raoult's stability criteria, which would be the various tools that we would essentially gain out of this particular course. And as we are learning the theory, we would also learn how the theory is going to be useful in practice. In this regard, there will be a few case studies predominantly towards the end of the course where real life data would be given and the participants would be asked to essentially apply ideas that have been learnt in this particular course and design controller. That would essentially provide the participants with a bird's eye view of the material learnt in this course and also give valuable hands-on experience, and a working knowledge of MATLAB and Simulink would be really helpful in that regard. So this in a nutshell, provides a few details about this particular course. So in summary, this course is expected to provide a second year undergraduate in engineering with some basic tools for control design, and this course essentially serves as a stepping stone to future advanced courses in controls that you may take. So best wishes to you on taking this course, and I hope you gain information that is useful to you. Thank you for your attention.